Alright, thoughts to another significant results video. We're still looking at some of our day 4 work, specifically problem 43. And it's a very complex scenario, but the most important part of it is looking at the two distributions of dot plots that are given to you. One of them is labeled as external, and one of them is labeled as internal. And that just goes back to the scenario that's presented about external rewards versus internal rewards. So they want us to compare those two distributions. And one of the first things you want to look at is the amount of variability. So let's go ahead and talk about variability here. If we look at the top distribution, that's external, and we look at the variability, it ranges from about 5 up to 25, so that's a range of about 20. And if we look at the lower distribution, that's internal, it ranges from what looks from about, down close to around 10, a little bit above 10 actually, all the way up to 30, which is again a range of about 20. So variability here is roughly the same, so I'd say external and internal variability are roughly the same. Alright. Variability also sometimes is referred to as spread. How far are they spread out? And then we're also going to talk about some other measures here of our distribution. What else can we go ahead and say about these particular distributions for number 43 here? The centers. If you look at the center of the data, and sometimes the way we refer to that is the balancing point of the data. If you had to balance the data, where would it balance? And I would say if I had to put my finger at some point for the external distribution, it's the top distribution with purple dots, I would say that it's going to balance somewhere in the upper teens. What about the internal distribution? Where is that going to balance? I would actually say that that would balance somewhere in the lower 20s. So what I would say is the center, so let's call that center. The center for internal, that's the bottom distribution, internal is greater than for external. Okay, great. So we've got that. We've talked about the center. What else can we talk about here for this particular one? Another topic that we could go ahead and discuss is, if there appear to be any sort of if there appears to be any sort of skewness, and I would actually say both distributions appear to be roughly symmetric. Okay, great. And are there any outliers, maybe? Well, I look at the top distribution, I see those points around 5. If there was just one point down there at 5, I would be tempted to say maybe it's an outlier, but we have 3 points down there around 5, so that's not probably going to be an outlier. It has company. Is it removed from the rest of the distribution by a good amount? Maybe so. But it's also, again, the point has company. So I'm not sure we can confidently say that's an outlier. And if we look at the bottom distribution, we see that there's a point up there at 30 all by itself. But then again, there's another point at 26 and some more points at 24. So it's not too far away. So I would say there appear to be no outliers. Alright, that'll do it for that particular problem. Our next problem is 45, and we're going to be finally looking at a stem and leaf plot. Here we have a stem and leaf plot that is for residents aged 25 to 34 in all 50 states. And we're measuring age 25 to 34. Excuse me, we're not measuring age. Let's continue. As in the stem plot for older residents, which was on a different page, page 33, the stems are whole percents, and the leaves are tenths of percents. This time, each stem has been split in two, with the values having 0 through 4 placed on the stem, and values ending in 5 through 9 placed on another stem. So, why did we split the stems is question A. So let's go ahead and write number 45A. Why do we split the stems? Why do you guys think we split the stems? If we hadn't split the stems, and we look at this, again, those numbers on the left side represent what? They represent our whole numbers, and the ones on the right represent our, what did they say? The tenths. They represent the tenths. So why did we split them? If we had too much data for, say, 11, which is on the left side, we might get a less subtle feel about the distribution of the data than we would if we were to split it from the lower 11s to the upper 11s. So 11.4s, we see that there's two 11.4s as opposed to, we also have two 11.6s and two 11.7s and an 11.8. Just one 11.8. What I would actually tell you to do is take the text that you're following along with and flip it on its edge. And I think what you'll see is you end up with something like this. Got two 12s, two 13s, two 14s, two 15s, two 6, and just one 16 actually. And we have some data in here, we have some numbers. And so, if you look at this and we were to... Oh, excuse me. Didn't mean to do that. Sorry. Let's go and erase that. Okay, so if we were to contour this, see, it sort of has that symmetric sort of distribution to it again. That's if you flip it on its edge. Of course, a stem and leaf plot usually goes up and down. So again, the first question A is, why did we split the stems? If we didn't split the stems, most of the data would appear just on a few stems. 13, we'd have, wow, if we had not split the stem into two 13s, the lower 13s here and the upper 13s here, we'd have all of that data just on one stem, and it'd be a less satisfying graph. We'd have less subtlety in our distribution, or what we could say about the distribution. So that's why it's split. So split stems for more accuracy and a better understanding of the distribution. Alright guys, that's going to wrap up this particular video. We'll hopefully have a chance to look at the other parts of that question together. And wish you luck, and I'll see you back here again later for some more videos.